Hey everybody, so I figured because calculating the orthocenter of a triangle given 3 points of a triangle is quite challenging, I wanted to make a video of just doing that again without the textbook stuff at all. So I'm going to go ahead and create a triangle in the coordinate plane. I'm going to plot a point here. I'm going to call these points, I guess A, B, and C. Now, in the book, we were given vertices, and so we had to graph them. Right now, I'm just making up my own triangle. So I'm going to go ahead and write out my vertices. A is at -1, -3. B is at 2, 0. And C is at 0, 4. And we are going to calculate the orthocenter. Now, whenever you're just given 3 points, there is a step-by-step process that you follow. First, you would want to graph your given points and construct your triangle. So graph the triangle. And here, since I made this up, I went ahead and just graphed my triangle first and listed my points. Okay, second, you would need to determine the slope of each of the sides of the triangle. So determine slope of each side. Okay, step 3, you would need to determine the perpendicular slopes to each side of the triangle. Okay, and then fourth, what you would need to do is you would need to use the point slope formula in order to write the equation of the line that represents the altitudes. And really, to solve for the orthocenter, you only need to find the equation of 2 of the altitudes and find that point of intersection because, by definition, the orthocenter is the point of concurrency of your altitudes. Okay, so I went ahead and paused the video as I hand wrote this stuff out. I'm kind of slow with writing by hand. So the orthocenter is the point of concurrency of our altitudes. We have 4 steps we have to follow so far. Step 1, graph the triangle. Step 2, determine the slope of each side of the triangle. Step 3, determine the perpendicular slope of each side of the triangle. Step 4, use point slope formula to write the equation of the lines representing each altitude. And I put a little note here. You truly only need 2 for this task. In case you don't remember what point slope form is, that is y minus y sub 1 is equal to m open parentheses x minus x sub 1, where x sub 1 and x sub 2 is the point that the line is containing, and m is your slope. So here, let's go ahead and dive in. Step 1 is already finished because of the fact that's, I did that first before writing the steps, so I'm going to put a check mark there. Step 2, it says determine the slope of each side of the triangle. So we have 3 sides of our, or to our triangle. So to calculate the slope, we can use our formula for slope, or we can do the counting for the rise over run. The one thing that's important here is that we actually annotate the different sides we're working with for slope so we can keep our work organized and neat. So I'm going to calculate the slope of side. I'm going to do AC first, where A is my first point, C is my second point. And the slope formula is y sub 2 minus y sub 1. All of that's over x sub 2 minus x sub 1. Since C is my second point, it corresponds to my sub 2 value. So my y coordinate of point C is 4, minus the y coordinate of point A, which is -3. All of that's divided by our our x coordinate of our second point C, so that's going to be 0, minus the x coordinate of our first point, which is A, and that x coordinate is -1. Now we're going to go ahead and simplify a little bit. So the slope of AC is equal to 4 minus -3 becomes 4 plus 3, which is 7. 0 minus -1 is the same thing as 0 plus 1, and 7 over 1 is just 7. Now, you can also use the counting method, and that's where you actually count how many units you rise up over how many units you move to the left or right to get to your next point. So I'm going to use that method for the remaining two sides here. Let's calculate the slope of side AB. And notice how I am annotating my work to keep up with my slopes. So starting at point A, I'm going to calculate my rise. I would have to rise up 1, 2, 3 points, or units, excuse me. And then I'd have to slide to the right 1, 2, 3 more units. Anytime I move up, that's a positive direction. Anytime I move down, that's a negative direction. Anytime I move to the right, that's a positive direction. Anytime I move to the left, that's a negative direction. 3 over 3 is 1. Okay, let's calculate the slope of this remaining side, CB. And I'm going to go ahead and use the counting method, starting at point C. And to get to point B, I would have to go down 1, 2, 3, 4 units. And then I have to run to the right 1, 2 units. So I'd have to go down 4 and to the right 2. So my slope is going to be -2. So I've completed the second step. This is a lot faster when you're not talking through it if you're just doing it. Anyhow, let's go to step 3, and I almost marked it off as done. Step 3 says determine the perpendicular slope of each side of the triangle. That upside down T stands for perpendicular. So I'm going to calculate the perpendicular slope of AC. That was my first side I worked with. Remember, perpendicular slopes are just simply opposite reciprocals of our original slope. So reciprocal means we're going to flip that fraction, and opposite means if it was positive, it's now negative, or if it was negative, it's now positive. So my slope for side AC was originally a +7, so the perpendicular slope is going to be -1 over 7. Okay, let's calculate the perpendicular slope of side AB. Okay, so side AB's slope was a +1, so the perpendicular slope would be -1. And let's calculate that perpendicular slope of that remaining side, CB. So CB's slope was -2, so the perpendicular slope to CB would be +1/2. Alrighty, so step 3 is finished. I'm going to go ahead and kind of annotate this over here. This is step 2. This is step 3. All right, let's go ahead and move into step 4. Step 4 says use point slope formula to write the equation of the lines representing each altitude. You truly only need 2 for this task. And I also forgot to write down what step 5 was. Step 5 is use 2, equations or altitude equations. Okay, since I am such a slow writer, I'm going to stop and tell you. Step 5 is you're going to use 2 altitude equations to solve the system of equations to locate that point of intersection. We're going to do it algebraically using substitution. Back whenever you were actually in 8th grade math or algebra 1, you learned how to solve systems of equations graphically through substitution and through elimination. Elimination is usually optional if the teacher has extra time, but I'm going to pause so I can write this. Okay, so I have that in there now. Let's go ahead and work on step 4 though. So step 4, use point slope formula to write the equation of the lines representing each altitude. So the point slope formula is y minus y sub 1 is equal to m open parentheses x minus x sub 1. I guess I'm going to go ahead and just work with, I'm going to work with vertex C. So I'm going to write the altitude that corresponds to point C first. So I'm going to write the equation of the altitude containing point C. And C is located at 0, 4. And it is perpendicular to the side opposite of it. So it's going to have the perpendicular slope to side AB. So I just kind of made a note to myself about, hey, what am I doing here? You guys need to make notes about what you're doing as well. So I'm going to plug in these values. I know that C is corresponding to my x sub 1 and my y sub 1. The perpendicular slope of side AB, that was -1. So my m value here equals -1, and I just got that from step 3. Now I'm going to take these values and plug them into my formula. So y minus 4 is equal to -1, open parentheses, x minus 0. On this right-hand side of the equation, x minus 0 is just x. And then -1 times x is just simply -x. I need to isolate y. Y has 4 being subtracted from it, so I'm going to add 4 to both sides of the equation. So y is equal to -x plus 4. So that is the equation of the altitude that contains point C. All right, now I'm going to go ahead and write the equation of the altitude. Containing point, I guess I'll do point B this time. And point B is located on the x-axis at 2, 0. And whenever I'm choosing my points that are being contained, I actually purposefully try to choose any points that have zeros because it makes this simplify a little bit easier. But it doesn't really matter. You can pick any points. But since I've chosen to include point B, I've got to work with the side opposite of B, and it's perpendicular slope. So the side that was opposite of point B was side AC. And that perpendicular slope of AC was equal to -1/7. So this B ordered pair is going to correspond to my x sub 1 and my y sub 1. And I'm going to use that point slope form formula. We're going to have y minus y sub 1 is equal to our m value, open parentheses, x minus x sub 1. On the left-hand side of the equation, there's nothing for me to do. It's going to just reduce to y. On that right-hand side, I'm going to distribute this -1/7 across that binomial. Remember, a binomial is a quantity that has two terms separated by addition or subtraction. -1/7 times x is -1/7 x. -1/7 times -2 gives us a +2/7. Okay, and so that is the equation of the altitude containing point B. Now we need to solve the system. So this was step 4 here. And for scanning purposes and for this video, I'm going to actually rip this off and get a new page. I could work right here, but I'm not sure about my space. So anyhow, I'm going to use these two equations to solve the system of equations. Here I have y equals -x plus 4. And here I have y equals -1/7 x plus 2/7. Notice I have two different things that are both equal to y, the same thing. And so we know by the transitive property that those two things that look different actually are equal. I mean, they're both equal to y. So we know that -x plus 4 is equal to -1/7 x plus 2/7. Has to be true because both of those things were equal to y. And I guess actually I'll go ahead and solve for x here. It's just I'll solve for y on the other page. A lot of kids don't like fractions, and it just, I don't know, I guess makes them nervous. And there's a strategy to eliminate your fractions and equations whenever you're isolating a variable or trying to solve for a variable. And that strategy is that you would multiply both sides of the equation by the least common multiple of all of the denominators. So these first two terms, they have a denominator of 1. I mean, you don't see it, but it's understood that it is there. On the right-hand side of the equation, both of my terms have a denominator of 7. So the least common multiple between all of my denominators, well, 1 and 7, is 7. So we're going to multiply both sides of the equation by 7. So 7 times negative x is negative 7x. 7 times 4 is 28. 7 times negative 1/7 gives us negative 7 over 7x, which is just negative 1x. Plus 7 times 2/7 is the same thing as 2, or not 2, excuse me, is the same thing as 14 over 7, which is just 2. Typically, people like to work with things that look like this. The fractions are gone. But anyways, it's fine. Whatever you prefer works best for you. That's good. So we have negative 7x plus 28 is equal to negative x plus 2. I'm going to go ahead and move my x terms over to the left-hand side of the equation and my constants to the right. So I'm going to add x to both sides of the equation. And so I'm going to have negative 7x plus 1x. That gives me negative 6x plus 28 is equal to this negative x plus x became 0. And we're left with that plus 2. Now I'm going to subtract 28 from both sides of the equation. And I'm going to be left with negative 6x is equal to negative 26. And at this point, x is being multiplied by negative 6. So to undo that multiplication, we need to divide both sides by negative 6. And x is equal to this negative 26 over negative 6. It's going to become a positive value, and the greatest common factor between the numerator and the denominator is 2. So this is going to reduce to 13 over 3. And that's the x-coordinate of our orthocenter. Now we need to actually find the y-coordinate. And so we need to plug the x-coordinate, or x, I'm going to go ahead and just call it an x value, the x value into one of the main or original equations involving this y equals the right-hand side. It doesn't matter which equation you choose. So you just plug it on in. I am going to choose to work with this one because it does not have fractions in it, whereas this one does. Because whenever I go to multiply these fractions, I'm going to end up with that denominator of 21, which I guess wouldn't be that big of a deal, truly. But anyhow, I am going to just choose to work with this one here. And I do have space. So I'm going to take this x value up here and I'm going to plug it in. So I've got y equals negative, that x is 13/3 plus 4. Okay, I cannot add or subtract two things unless they have common denominators. So this 4 has an understood denominator of 1. So I need to multiply 4 by 3 over 3 to force that common denominator. And that's going to give me 12/3. And then when I combine these two like terms on that right-hand side, I find that y is equal to negative 1/3. So I've got my x-coordinate of my orthocenter down here, and I just found my y-coordinate of my orthocenter. So I know that the orthocenter is 13/3, comma, negative 1/3, and that's it. It seems kind of, tedious when you're looking at it like this way, but you guys, I was just writing a whole bunch of steps out. You don't have to do that when you're solving your problems. And honestly, I'm not even so worried about like seeing the slope part. This is just a good way to get it in there correctly, or solve the problem correctly. But hopefully this is helpful. Thanks. Bye.